Welcome to Easy Math TV. This is another video in our series on our statistics and basically walk through videos for our R labs that are going to help us understand statistics a little bit more. Going over to our files, there's going to be two videos in a row here. There's going to be a walkthrough for our inference for categorical data. We're going to do that one right now. And then inference for numerical data is going to come right after this one. So these are all of our labs over here. So let's go to the categorical data one. And I just want to point out that there's a couple more resources here for you that that I just want you to be able to use. And you're also seeing kind of a little bit of a history of what I've already typed into the console. I'll explain to you why I did that in a moment, because there's a certain a certain function that you're going to be using that when you type it in and you go to run that, it can take up to 10 minutes to install all of the packages that are needed for that function. So it could take a while for that to complete everything that it needs to complete. So so that's why I'm not going to undo that. So basically there's two things that we need to be looking at here before you even start. So the first thing you need to be looking at is the lab itself. So the lab instructions walk you through here, and I've had to alter some of it because like there was a link here that was broken, and so that means that the survey that you're going to be relying on is no longer at that site. But fortunately, the survey is included in our lab here. So those are the instructions, the inference for categorical data, and with your exercises that you need to answer. The exercise questions are here, and there are 6 of them, I believe. No, 7. Oh, more than 7. 8, 9. So there are 9 exercise questions for this one. But they're more like, do you understand these concepts kind of thing? So you can see that there's not a lot of R code involved. The exercises are really just asking you to interpret stuff that you're reading. So there is going to be some reading involved for this lab. The other thing that you're going to need is in this folder called More. So I need you to open that folder that says More. And then I need you to open this PDF document here that says Global Index of Religiosity and Atheism. So this was a survey that was conducted by Wynne Gallup back in 2012. They did a global index of something called religiosity, which basically measures people's attitudes towards religion. Okay, and this was a pretty large survey. There were over 88,000 people that were part of this survey, and many countries. Like if you read this document, which you have to do, like you need to read through this entire report. Near the end and everything, it shows you what countries were included in the survey, and just to try to get like a benchmark of what global attitudes are towards religion. All right. And what we're going to be doing in this lab is we're going to be doing some inference for the population proportion of people who are atheist or who consider themselves to be atheist. So as you can see, there was a lot of stuff that had to be downloaded here. And the other thing that I made available to you just to make things easier is I've actually given you the file that has the R code in it. So we're going to open that file right now, and that's called inferenceproportion.r. So I'm opening the file, and it appears in the upper left of your Posit Cloud window. So now we have the upper left Posit Cloud window is going to be where we're going to get our R code from. Any output from our calculations is going to appear down here in the console, We're also going to be making some plots, so we want to make sure that we can see the plots. And then the data that we've created is all up here in your environment. So right now your environment's empty, but once you once you install the data, you're going to see it up here. Okay, so let's just go over that real quick. So these 3 lines right here of code where it says download.file and then there's an HTTP website, all you have to do is highlight all of that. And you can either just highlight it and click run, or you can highlight it, copy and paste it down into the console. So that's up to you. I've already done that, so I'm not going to do that here. But when you run that data, you're going to see this will get printed out. Sorry, not that, just this part. This part you will see printed out, and then you will see this that I'm going to expand. So you're going to see the data called atheism, and there's 3 variables, nationality, response, and year. So the nationality is just the country, the response is atheist or non-atheist, and then the year is 2012. Okay, so this tells you that you've got those 3 variables that are involved, and it tells you how many observations you've got. So what we did was we separated out just the data for the United States, and that's this line of code you see here where it says US 12, so that's just United States 2012, and we're using the function subset, so we are subsetting our data atheism by just nationality equals United States and year equals 2012. So up in our environment, that's this data set right here, US 12, and instead of 88,032 observations, we now only have 1,002 observations. Okay, so that's the data. And then the directions for the lab have you creating a 95% confidence interval on the true proportion of citizens, in this case in the United States, who identify as what we call a convinced atheist, because they use that phrase in their survey. So that could have confused a few people, like what does convinced atheist mean? Because I've met a lot of atheists who are just who say they're just agnostic, and so they might not have known how to respond to that question. But anyway, that's neither here nor there. So what you see me highlighting right here is the new function that we're going to be using between this lab and the next lab on numerical data. It's called Inference. And the Inference function is very, very complicated. Like it can do a lot of different things. It can create confidence intervals, but it can also do a hypothesis test. And it can do a confidence interval or a hypothesis test on a proportion, on a mean, on the difference between 2 means. So it's very useful in doing a lot of inferential statistics. Okay. I'm going to scroll down here because right here is where you see where I actually ran the code. Okay. And then I saw this long list of output, like had to wait for a very long time for this to process. And so before you actually do that, I just want you to know, like, you're going to have to be patient and let it run through the entire thing. And this is what you're going to see on the screen when it's done. By the time it's done, you will see these blue arrows in the lower left corner. So those are called the cursors. And those blue arrows that appear in the lower left corner of the console are an indication that's done. And you notice that there's no red stop sign up here that's showing that something is running. And you're also going to see this plot here. Okay. Now I'm just going to run that one more time. So now that I've already installed all of those packages. Like if I run this now, it's not going to take forever, like it did before. So I'm going to go ahead and do the inference again, and I'm going to see this output produced, and I'm also going to see that plot. So I'm going to hit enter, and there we go. So the output is in the console, and it says single proportion success. Success is being measured by whether or not, like, by the fact that someone responded atheist. So that is telling you how we're counting our X's. Our successes are that a person responded to the religion question as an atheist. Okay, here's our summary statistics. Our p hat is 0.0499, so almost really close to 5% of the people surveyed said that they were atheist, and that's just in the survey. So n was equal to 1002. Okay, and then part of your lab is to check your conditions. So here's our check conditions. The number of successes was 50. The number of failures was 952. Okay. And then we also have our standard error was calculated. And then here's our 95% confidence interval. So I'm going to let you decide what to do with that information. I'm not going to help you right here in this video with what to do with those numbers. That it's up to you to understand or to know how to apply that output that you see there. And on the right, we have our plot. We have our like bar chart that shows us the difference between atheist versus non-atheist. Okay. And then the only other R code that you're going to need to run here is basically it's a simulation. So we're going to be seeing how we're going to demonstrate the relationship between a proportion P. So like this can be a population proportion. So what is the relationship between the proportion and margin of error calculations? So based on a certain sample size. So like in this case, n is equal to 1000, and that's just a fixed value. But then we're going to have like a whole bunch of values of p, little p, from 0 to 1, and they're going to increment by 0.01. So there's all kinds of values of p. For each value of p, we're actually going to calculate the margin of error here. So that's the margin of error calculation. And then we're going to plot them against each other. So like on an X and Y axis. Okay. So I'm just going to highlight all of that and hit run. So you're only going to have two plots to look at for this lab. The first one was atheist versus non-atheist for the United States and for two other countries that you have to choose from. So basically, I guess that means you're going to have three plots because there will be the United States plus two other countries that you select. And then we have this, our population proportion compared to the margin of error. So the margin of error is on the y-axis and the population proportion is on the x-axis. And what does this mean? What does this arc actually mean? I'm going to ask you to think about that and try to respond yourself. But that's basically all of the R code that we're going to need for this lab. You will be, by the way, you will be creating your own separate observations. You're going to like be doing this a couple more times. So up here where you're subsetting, you're going to pick your own countries and you're going to subset the data by those countries, and you're going to, store those in a vector that you choose. So, let's say it's Ukraine, you might call it UKR12 instead of US12, and just instead of United States, you're going to put Ukraine in here. And then you're going to do the same confidence interval inference on that. And so you're going to replace US 12 with the country that you decide to do, like the two other countries. Okay. So yes, you are going to need to replace a couple of variables, but that's it. Just those couple things, and create your own confidence intervals for that data. All right. So that's it for our walkthrough for Lab 7 on inference on from categorical data, basically inference on a proportion. Okay. Like, subscribe, comment down below, and I hope you find these videos helpful in your study of statistics and in using R to help you study statistics.